Today's trek into DIY tech is going to be a look at some what some would call ancient technology. This this is a robot that I designed over 11 years ago. It's over 11 years ago. So this thing, we're gonna go over this thing today and what it is and how it works. Almost looks like a crab there, doesn't it? So yeah, we're gonna take a look at that today. All right, before we take a look at the actual artifact, what we're going to do is we're going to go over what actually constitutes a robot, or what you would think a robot actually is. A lot of people use it interchangeably between remotely operated devices or things that you operate remotely. So, for example, and by the way, if you want to see more on the sumo robot, check out the link over here, or the link in the description. There'll be more on that, as well as, you know, the Bluetooth controlled Zumo tank. There'll be links for both of those, so you guys can see the videos on each one of these. But what we would normally call a robot is a system that can do automated tasks. So you program it, it continuously does the task until you tell it to stop, right? So, or it can do some processing, and an action happens behind that processing. So cause and effect there's some input, and the effect goes through some processing, and then it outputs an action. So for example, our sumo robot has a myriad of sensors on it all the way around, IR sensors and ultrasonic sensors. Detects an opponent and it moves towards it and attempts to push it out of the ring, right? So that's our sumo robot. It's functioning by itself. We just turn it on, set it at the start line, and it goes. In contrast, we have our Bluetooth controlled tank. So this guy, you turn it on, he's just gonna sit there and wait for you to have some input. You know, this particular one can connect to a cell phone, and you have your controls on the cell phone, and you basically drive them around, right? So in this example, we have both of these bases are the same. So this is the Zumo, Pololu Zumo base. They're exactly the same in all other respects. This one does his processing on board, acts on some input, and has an output. This one does no processing on board, waits for the input, and then which the input, no processing here, no processing here, because you are the processor here. So robot, unmanned vehicle. All right, so cool. So now we know the difference between the robot or you know, what we're using to define robot in this case. So this guy here, about 11 years ago, I have some footage that I'll show you in a moment on its functionality. So this one has a basic stamp microprocessor on board. So you guys are familiar with Raspberry Pi and Arduino. This one's actually a what they call a basic stamp, and it was put out by Parallax back in the day. They're still available today. It looks very close to some of the smaller Arduino, and even now some of the Raspberry Pi boards are coming in this footprint. And they're now that size. But if you look on here real close, that's not a through hole. That's not a through hole pin, right? What? What's going on there? So the pins, very distinctive thing about the basic stamps. And I'll put a link to the Parallax page on there so you guys can check out the basic stamp yourselves. These pins were, if you look on the edge, you can see that they wrap around the edge this way. That makes for a very thin pin on this side. I won't pull this out only because this is my one and only basic stamp, and so I don't want to take a chance on bending the pins and so forth. But you can get a really good close look at the at this link that I'm gonna set there for you. So the premise behind this guy was, and I'll show you here, was that a bunch of these guys could be dropped from a plane, and so you would have a biodegradable cylinder, right, with a bunch of layers, kind of like a cake, right? And so parachute, not to scale, guys, not to scale. So the parachute would have some method of flying it down to some building that had collapsed, and this was intended for searching collapsed buildings for survivors. And so there are sensors on the robot. But anyway, the robots would reside in here. This canister would be dropped from a plane into an inaccessible area, and these guys would be sitting in here like a swarm, ready to be released. And so this biodegradable canister would land into all this debris, and these guys would jump out, crawl through this wreckage, and mark all the spots for first responders to hit first. So, you know, if they found somebody here that that would be a spot that one of these robots would actually come over, crawl through this wreckage as the rest of the swarm is going through, and the robot that got to this person, either by thermal, thermal sensing. Back then, this whole thing was the sensors and the technology that was available back then is not what it is now. If you wait a few months, something new in electronics will come out and make something else obsolete. So that's what eventually happened to this little guy. So now that I've shown you that, we'll go through the rest of how this guy works. So we have a battery pack here. There were two other iterations of the battery pack, which you can see there. This is a custom-made battery pack. I included fuses and polarity protection here, so that it was just easy to use. And you can see the screws here. These screws come out. You can replace battery packs. Lithium polymer came out, and charging boards that you could just integrate into your systems came out. And so we have the charging board. We've got a buck there to give us the proper voltage, because this is 3.7 if I'm not mistaken. We needed 5 volts, so this BEC converts the 3.7 that's charged up by this. And check it out. This is a mini USB and not a micro USB. Right? So this board charges up this battery, This battery goes through this buck converter, turns back into 5 volts, and that's what powers this whole deal here. Now, I'm going to show you some old footage of how this works, or how this guy functions or walks. This is the first iteration, so the legs are just for, proof of concept. It walks across the table, and sensors pick stuff up, and so forth, right? So, and of course, eventually it would get miniaturized into a size that, once dropped into debris, it could actually move around and find, find its target. But, and again, here we've got 3 servos. Servos have shrunk by factors by this time. But this is all done on a Radio Shack perf board. We're gonna save that for another video, using PC boards to make your projects more permanent. But that's what I used in here. And we'll see if it's got enough power to power up. There you go. I had status LEDs. So this is an RGB or RG. It's only got red and green. But by using red and green, I was able to get amber. So I would get green, red, and variation of amber. Power indicator. We had a status light to indicate that what modes we were in, and a user or 2 user interface buttons. This is actually a reset, and this is your user interface button. So let's see. This is the standby mode that I just put it on, and you can see this kind of looks amber, greenish, reddish. And if I press it again, it will attempt to walk. So you'll notice that these legs are in pretty bad shape at this point. I'll shut her off so that you can hear. Okay, so we put her back in standby. So this was anyway. So that's the test sequence that it was going through. So here, this is some vintage footage of the testing I was doing, and you can see that it does get some motion. You can see also that the legs are in their original shape. So I'm going to explain to you what happened to those legs in a minute here. But yeah, that's going forwards, left, right, and then backwards. So just a little quick test to verify that everything is functioning the way it should be. These legs, while I was running the makerspace, there were many years that I was running a makerspace, and we had this one situation or incident. So we had one child who was very interested in how this robot worked. Set up 2 tables. And between the tables, set up a piece of paper. Now, the paper was not taped to either table or supported in any way, so that when he started the Rubble search robot walking across, it got to a certain point and dropped down between the 2 tables, and the legs took the brunt of the impact and folded up. So nothing else was damaged, but the legs wound up getting bent, And so subsequently, he went on to try to repair the legs, and so started bending the legs back to where he thought the legs were originally. And well, suffice it to say, the legs did not get back to the way they were originally, and the bending back and forth actually caused fatigue, enough fatigue in the metal to where we lost a few sections of leg. And anyway, suffice it to say, Rubble Search Robot is retired for the foreseeable future. I don't know if you guys get interested enough in this, or I hear in the comments that you guys would like me to reconstruct this or remake it with today's materials. I would certainly entertain that. But this is this is the Rubble Search Robot. I'm going to show you now, in case you're interested and want to see a little bit on this. I'm going to show you what the programming language for or the IDE, or what they call the development environment, integrated development environment. Interestingly enough, this robot, the programming language is called PBasic. Back when I started programming, or today we call it, it's coding. All right, not to, not knocking anything, but so today it's coding. Back then it was programming. So yeah, I have seen punch cards as well. That's very funny. Okay, but it was I learned. Well, there's Pascal, there's COBOL, there's all of those, and then there was QBasic, and QBasic came with Windows, the original DOS kernel Windows, and there was QBasic in there, and it was a language that was meant to be very close to English. So as you can imagine, the idea there was obviously to make programming easy by having you program in English, basically. And the thing was, you have two different types of applications for programming. So you have compilers, which they take what you write and turn it into ones and zeros, basically. That's another video again. And then you have interpreters. So interpreters will work a process on what you write. So it'll take, the lines of code that you write and interpret them into something that, just like a language interpreter will interpret those lines of code into something that the microprocessor can act on or understand to carry out what you're telling it to do. So this is what PBasic was, intended to extend QBasic by making it an easy entry. You use the same commands, and it would be easy for you to move from QBasic, basic to PBasic and program these microcontrollers. So this is, I'll just give you a quick, overview of it. All right, guys. So here you go. Here's the Parallax website, and hey, made in the USA. So let me show you. What's the best way to do this? Let's go to. Those are the. Let's go to the shop. And so what we have is the basic stamp 2.
Ooh, these allergies are killing me. So check it out. Here's the basic stamp 2, and let's go ahead and take a look at that guy. And as you can see here, there's a close-up of the pins I was showing you. They have the IDE that I'm going to show you here in a second. This is pretty cool, the tokenizer. So what that allows you to do is once you create your program in the IDE, you can actually use the tokenizer to turn it into an exe file. So for example, if you just want people to be able to get their own basic stamp, and you want to pass on the program without them having to open the IDE themselves and go through all that, they can go ahead and run the exe, and it will take care of loading the software onto the basic stamp itself. But anyway, there it is. It's a very cool little microcontroller. And here are all the resources you need to get going on that. So yeah, that's on the right there on the Parallax site. I'll put a link to it in case anybody didn't catch that. But also what we have in here, so I'm going to open up the IDE for you so you can check that out. I'll show you what that looks like. So it always comes up with these little tips. So every time you open up the IDE, it gives you another pro tip there. So that's pretty cool. But as you can see, I have a lot of projects in this folder. We're down to Rubble Search Robot, and we're going to do Rev C, Rev C, which is the latest one, and basic stamp. I also have Maestro files, that's another microcontroller, but that one just concerns servos. So basically it's a servo player that you can run scripts on, and it'll run your servos for you. But that's for another video. But here you can see I have different tests. Usually I run a test program, as I put functionality onto the robot. So this is a switch test. So this is the operators, or the switch that you actually switch modes with. Is that this is a slightly more complex switch or servo test, slightly more complex than the switch test, which is the servo test, and it just puts the servos through a full range of motion. So it goes about 180 degrees on each servo in turn to check the movement on the servos. And I always comment everything, so years later you will never remember what you wrote. So always include comments in all of your programming. Also, so that if somebody else picks up your program, they can go ahead and know what you intended to do with that line of code. But wow, yeah, 2011, February 2011. Wow. Here's the op program, which is short for operational program. Yeah, we won't go through this later. If you guys are interested, let me know in the comments, and I'll do an in-depth on the on how this program works. But how many lines do we have there? Let's see, 177. Wow. Um, but anyway, that's the IDE. Just real quick.
All right, so there you go. That's the our Rubble search robot. Little piece of ancient technology. And again, as always, any questions, put them in the comments. I'll try to get to them as soon as possible. And hey, if you want to keep this channel going, like, subscribe, share with your friends. We're also getting a Patreon going in case you want to contribute that way. All of that will be down in the description. And thanks for watching, and we'll see you in the next video.